In previous session, I explained about the linear regression. Linear regression there are the two types. One is the linear regression, another one is the multiple linear regression. These two are the statistical techniques to build the relationship between the dependent variable and independent variable. For example, coming to the linear regression and simple linear regression both are same. If we used one independent variable to predict the dependent variable, it is the simple linear regression. If we used two or more than two independent variables to predict the dependent variable, we called it as the multiple linear regression. In simple linear regression, we used only one independent variable to predict the dependent variable. It automatically correlate with the relationship between the independent variable and dependent variable. So I already explained this one. Equation for the simple linear regression: y equal to beta naught, this is the constant, plus beta 1 x. Here beta 1 is the coefficient, x is the independent variable, this is the error we got while predicting the new variable. For example, whenever after building a model, whenever we get the new customer and new data point, we'll try to predict the output for this new independent variable. Based on the new independent variable, we'll predict some output. But let's see, no model gives the 100% accurate output. Just everyone gives 99% or 99.9%, but no model gives the 100% accuracy. There must be some error, that is this one E. Okay, you people are aware about the y is the independent variable, x is the independent variable. These two are the coefficients. This is the constant coefficient, this is the independent variable coefficient. E is the error. Coming to the multilinear regression, here we'll use two or more than two independent variables to predict the dependent variable. For example, let's assume there are two independent variables. So the equation will modify like this: beta naught, constant, and error. These two are always safe. But how many independent variables are available in input? We'll calculate coefficient for the each and every independent variable separately. How do we calculate this coefficient value? Based on the relationship between these independent variable and dependent variable. These, how do we calculate beta 1, beta 2, or beta 3? If we have the third independent variable, we'll get the beta 3 plus x3. So this coefficient will calculate based on the relationship of the dependent variable to the particular with x1 independent variable. Okay. In multiple regression, the goal is to estimate the values of coefficient beta naught, beta 1, beta 2, extra. How many independent variables we are available in the data? We need to estimate the values of the coefficient for the all, and for example, each and every independent variable separately. So summary means the linear regression means if we have the single independent variable, it is the linear regression. Whereas multiple regression deals with two or more than two independent variables. Okay. Linear regression main concept is that to find the relationship between the independent variable and the dependent variable. If we use one independent variable, we call it as the simple linear regression. If we use two or more than two independent variables, simply we call it as the multiple linear regression. That is the difference. Model building, predictions, everything are same. In multiple linear regression, based on the independent variables, if we have the many number of independent variables, out of those, some are unwanted, some are wanted, we'll try to duplicate, drop the unwanted variables. But coming to the linear regression, here we are using only one independent variable. So here we won't have any chance to drop the unwanted variables. Why? Because we have only one variable. That's the main difference, nothing. Okay. This is the previous session what we discussed. Coming to the logistic regression. Logistic and linear. These two also statistic techniques for the model building relationships between the variables. For example, let's take in previous session I explained linear regression. Linear regression means it's the relationship between the dependent variable and independent variable. Here dependent variable means it depends on the other variable. That's why we call it as the dependent variable. For independent variable means it won't depends on the other variable. So it is the independent variable. To build while building model, we need one input and one output. For example, let's take, if we want to predict stock price of the today's stock price, we need to provide some information to predict the stock price. The what is the information we provide in as a input? It is the independent variable. What is the output we are expecting? That is the dependent variable. So the output always depends on the input. That's why that is the dependent variable or target variable. The information what we are providing as a input to the model, that is the independent variable. Okay. Maruti, are you able to understand what is the dependent variable or what is the independent variable?
Yes, ma'am.
Yeah. Actually, previous section they already know, they are already aware about the dependent variable, independent variable. See,
Okay, ma'am.
coming to the we'll say about the regression model. Previous section I explained linear regression model. Linear regression means it's the statistical technique to build the model. It's pure. It depends on the, for example, relationship between the dependent variable and one or more independent variables. The main difference between lies in the number of independent variables they consider. In linear regression, there are two types of regression. One is the simple linear regression, another one is the multiple linear regression. Simple linear regression means here we'll use only one independent variable, one dependent variable. Dependent variable always is one. Why? Because we are expecting only one value from the model. So dependent variable is always one, but independent there is a chance it's our choice to choose whether one independent variable or more than one independent variable. If we choose only one independent variable, it we called it as the linear regression, simple linear regression. If we choose two or more than two independent variables, we call it as the multiple linear regression. Let's see. For this single linear regression, that is the simple linear regression, the equation is this one. Y equal beta naught plus beta 1x plus error. E means error. Here, y is the dependent variable, what we are expecting. X is the independent variable, what we are providing as an input. Beta 1 is the coefficient. Coefficient means the relationship between the x and y. There is a chance positive correlation or negative correlation between the x and y. For example, if x increases constantly, automatically y will also increases constantly. That means that there is the positive correlation between these x and y. What we call it as the, if both are drastically increasing, that means direct proportion. Direct proportion means positive correlation. If the x continuously goes up but y continuously goes down, that means the indirect proportion. That means negative correlation. Negative correlation. But we won't say a positive correlation means this x value gives the have the more information about the y value. But coming to the negative correlation, that means this x value doesn't have any information about the dependent variable. We won't assume like that. We need some relation between x and y, whether it is positive or negative, no problem. That means, for example, if there is negative correlation, whenever x increases, we'll get some sense. Yes, here x is increased. That means y will there is a chance to decrease y. That is also one prediction, one reason. That is also one of the information while to predict the dependent variable. Okay. If there is no relation between x and y, that means this x value, that means this input is not useful to predict the y. Okay. Simply linear regression is the relationship between independent variable and single independent variable. Maybe that relationship may be positive or negative. It's not the matter. Whether it is positive or negative, it's not a matter. X have some information positively or negatively about the Y. It's a good thing. But if there is no relation between X and Y, that's the bad thing. If X doesn't have any information about Y, we won't predict expected Y value by using this X value. Okay. So we need to calculate coefficient value which gives the expected Y value by using independent variable. That's the main thing what we to do while building model. Okay. Linear regression model is this one. Here y is the dependent variable, x is the independent variable, beta naught, beta 1 is, these two are the coefficients. E is the error. Error means no model gives 100% accurately what we are expecting. It gives the 90% or 95%. What is we are not able to predict 100%, those 5 or 1%, we call it as the error. Okay? We call it as the error. Coming to the multiple regression. Here in simple linear regression, we used only one independent variable. Here in multiple regression, we'll use two or more than two independent variables to predict the dependent variable. Okay. Previously, we have the one independent variable. That's why we gave the equation beta 1 x1 plus error. Let's assume I have the two independent variables. So beta naught plus beta 1 x1 plus beta 2 x2 plus error. If I have four independent variables, we'll add plus beta 3 x3 plus beta 4 x4 plus error. Okay. We need to calculate coefficient or relationship between the y is dependent variable, dependent variable to the each and every independent variables. How many independent variables we have, we need to calculate that many coefficients. Okay. This is the linear regression. We'll explain through code in our next session. So same thing here we'll give the multiple regression to estimate the values of coefficients for the each and every independent variable. How many independent variables we have? We need to estimate that many of coefficients for the each and every independent variable to fit the best fitting residual line. Okay. In today's session, coming to the logistic regression. Previously, we learn about the linear regression, multiple linear regression. Both are the same thing, regression. But here coming to the logistic regression, actually the difference between the logistic regression, linear regression means type of the dependent variable they can handle. Type of the dependent variable, that means y variable, that nature relationship they present. For example, coming to the logic, uses sigmoid function to map the linear combination of the independent variables and coefficient into the probability between 0 and 1. Previously, if we have the price value, price shall we able to classify price may be more than 1 lakh, less than 1 lakh? No. Based on the area, number of bedrooms, square feet area, there is a chance to vary house price from the 1 lakh to 10 lakhs, 10 lakhs to 1 crore, 1 crore to 5, 3 crores, like that. We won't say it lies between this one to this one, like that. At that scenario, that means what we call that type of information, continuous numerical data. Okay. Continuous numerical data. Whenever the output or dependent variable is continuous numeric data, we use the linear regression to predict the data. Okay. Coming to the, for example, let's take whether the mail is spam or not spam. We have the data set 100 points. Out of the 100 points, 100 mails, we have the 60 are spam mails, 40 are non-spam mails. By using that data, we will build model. Whenever new mail come, we need to classify whether that mail is related to the mail, mail is related to the spam or non-spam. Here, we won't try to come outcome y equal to beta 1 plus beta naught plus beta 1 x plus exactly. Here we won't try to calculating the exact y value. Here in logistic regression, we try to get the probability. For example, actually, how many mails we have at the while training the model? 100 mails. So out of 100 mails, whenever new mail comes, it will become 101 mail. So out of the 101 mail, what is the probability of the input mail? Whether it is related to the one, we say it as the spam mail. Whether it is near to zero, the probability is near to zero, we say it as the non-spam mail. So here we are calculating probabilities. Whenever the dependent variable is the categorical variable, we'll use logistic regression to predict the probability of that new input. People, are you able to understand when we use linear regression, when we use logistic regression?
Yes.
Linear
Yes, ma'am.
regression is used for the continuous dependent variable.
Continuous numeric
Yes,
data.
yes.
Yes.
While logistic regression used for the categorical or binary dependent variable. Binary means there is a two chances whether it is and another,
Zero or
otherwise
one.
that one. Actually, there is
Zero
in
or one.
categorical data there is a chance. For example, let's see we have the lot of library. We stored the we stored all information, each book information one in one data set. Due to some reasons, we lost that library in some fire accident, but the information have each and every book content is we already stored in one data set, computer in some database. But the people who want to read about the mathematical textbooks, how do we know that one? There are, for example, 10,000 or 20,000 books. How do we know which one is the mathematical? We can't open each and every file. We won't check. It takes so many days. So there is a chance for the six different types of textbooks. Out of the 20,000, 6 or 10 different types of textbooks. We need whether it is maths, English, social science, Telugu, Hindi, like this. Let's consider our output is maths, social science, Telugu, English. Whether it is continuous data or categorical data.
Categorical.
Categorical. Why? Because there is no difference between the maths and science. There is no difference between the science and English. Each and every class have the same priority. So, so if there is only two categories, we call it as the binary dependent variable. Whether it is spam or not spam, it comes under the binary dependent variable. Whether it is maths, whether it is science, whether it is English, if we have the two or more than two categorical data, then we call it as the categorical dependent variable. But for the categorical or binary dependent variable, we'll use logistic regression. Okay, I said yes, we have the categorical data. So logistic regression is best to use the categorical data. Why we won't use linear regression for this categorical data? What will happen if we use linear regression on this categorical data? Let's say classification task. For example, which are spam mails? These are the S equal to 1. Which are non-spam mails? That means the no equal to 0. Try to fit linear regression. In previous session, I told you there is a linear regression have the best fit line. Okay, these are the expected x values all under this line. If the x values are near to this value are there, we call the distance between the predicted value to the actual value, we call it as the error. Okay. Yes, that one the linear regression. Coming to if we try to fit this linear regression line here, let's see what we call these are all are near to this line. How do you say which is spam, which are not spam? Shall we able to differentiate the data points which are above the linear regression line? These are the spam. Which are below the linear regression line? These are non-spam. No, we can't say. Why? Because here these 2 points, which these two are above the linear regression line, but these are not spam mails. Here these 2 points, these are below the linear regression line, but these are not spam, non-spam mails.
Correct.
Okay, yeah. If, for example, I want to differentiate these two correctly, Let's see, we'll take one line like this. Okay, what will happen whenever new point comes? If we do like this, whenever new point comes, yeah, we can't fit the, yes, we can't fit this categorical data on the linear regression. That's why here we are using logistic regression. Okay, in linear regression, I told you already, we'll assume the data have the linearity. That means the data goes up or goes down continuously. There is no fluctuations like this, like a wave. Okay, the data will be have linearity like this or like this, not like this. The points somewhere randomly. If we have the data like that, we linear regression won't give any results as expected. But coming to the logistic regression, there is no assumptions. Logistic regression work on the whether it is linear data or non-linear data. It won't think about the whether it is linear data. The data type linearity and non-linearity won't impact on the logistic regression. Okay. In ordinary least squares is inappropriate. That means least square. Previously we measured MSE, mean squared error, to calculate the error on the model. Here in logistic regression, we use the maximum likelihood estimation. Okay, maximum likelihood estimation means we need to check probability. For example, let's say it is the spam. So the probability is the 0.6%. It is more than 0.5. Actually, for let's assume it is the binary classification. We have the two categorical data independent variable, whether it is 0 or 1. So we'll take 0 is the non-spam, 1 is the spam. What is the threshold for to differentiate this spam and non-spam mail? 0.5. Okay. If the probability is more than 0.5, we'll say it is the spam mail. If the probability is the less than 0.5, the mail is the non-spam mail. If the probability more than 0.5, it is the spam mail. Less than 0.5, it is the non-spam mail. Okay. We'll say how to measure error, everything in next slides. What are the some scenarios under the logistic regression? Mostly we call logistic regression is the classification algorithm. So we need to classify the files which are related to the maths or science like that. Some examples is email spam or not, online transactions, whether the transaction is fraud or non-fraud, like this, tumor malignant or benign. So logistic regression transform its output using the logistic sigmoid function. We'll say what is the sigmoid function. Let's see. Coming to the linear regression, just we'll try to uh, fit linear regression line like this. But coming to the this logistic regression, it won't work. For example, let's say the points which are near to this line, the MSE, mean square error, is very less. See, let's assume this point to the this, there is lot of distance between this one to this one, but it is the completely non-spam mail. That is the 0. It is the related to the class 0. It doesn't have any error. But whenever we try to calculate error, what we do? We'll try to find distance between the linear regression line to this one. What it says, it has a lot of error, so the predictions are very bad. But in real time, the prediction is very good. Why? Because Y0, that means non-spam mail. Here Y1, that means it is the spam mail. Prediction is good, but MSC value is very high. To eliminate, so linear regression,
Ma'am, like which
like
one is the most accurate one among these two?
for the linear regression, this one is the one, but this is the logistic regression problems. Here X and Y, it says the logistic regression categorical value. Here X and Y is the logistic regression categorical value. See, whenever we try to linear regression, let's assume if we draw like this, we'll calculate the errors from the this value to this value. Okay. What is the distance between the linear regression line to given input value? Hello.
Yes, ma'am. Yes,
What
ma'am. Yes,
we
ma'am.
get, there is
Yes,
a,
yes, ma'am.
let's see, there are lot of points which are near to regression line. These will get only less error. But coming to
Yes,
the,
ma'am.
let's take last point, it gives the high error. But
More
the
error.
probability
Yes.
1 is correct. The probability 1 means it is the good probability, but it gives the higher. That's why instead of using this linear regression model, we'll use this sigmoid function to differentiate the spam and non-spam in logistic regression. Okay. For the linear regression, we'll use this linear regression model, but it is not work on the logistic regression. That's why we are using this sigmoid function. This S is the sigmoid function. We'll use this sigmoid function instead of linear regression model. Okay.
Okay.
Let's see. If let's assume this is the sigmoid function, we know there is let's see, sigmoid function like this one, here to here to here. If the points extends like this curve also extends like this. If the points goes like this curve also goes like this. Now you can try to measure error. The distance between this sigmoid function line to these data points are very less. As here the distance between these points to this sigmoid function, this value is very less. Okay.
The probability of getting one is more, no, ma'am.
No.
In
Here, for
logistic.
example, we have the two types of mails. Okay. If we predict probability as a 0, it is the non-spam mail.
Okay.
If we predict the probability is 1, that means a spam mails.
Yeah.
But every time we won't predict 1, 0. Probability is always lies between 0 to 1. There may
Yes,
be a
ma'am.
chance of 0.4, 0.6, 0.75 like that. But we consider here 0.5 as the threshold value. Okay. If the probability is more than 0.5, we treated that mail is related to this spam mail. Okay. If the probability is less than 0.5, we treated that mail is the non-spam mail. But don't fix the probability is 0 is always non-spam mail. Just I am taking example as the spam and non-spam mail. There is a chance of probability related near to 0 is the spam mail. Probability near to 1 is a non-spam mail. It depends on the input data. Just for easy understanding, I am saying actually previously we'll use y equal to beta naught plus beta 1x plus e to estimate the y value. Whenever new data point comes, it will have the x value, x2 value, x3 value. By using x2, x3 value, we already have the coefficients. While training the model, we'll calculate the coefficient for the each and every independent variable. So whenever new data points comes, we'll substitute new data x1 x2 on those equation. We'll predict y value, but here we won't predict like that mathematical equation. Here we'll do probability. Here we'll try to calculate the probability. In previous session I already explained you how to get out of the free words what is the spam, what is the probability to come spam. Okay, like that here we'll use probability to calculate the logistic regression. Guys, are you clear?
Yes, ma'am.
Yeah. Just here we modified the function. Previously we used y equal to mx plus c. That's why the linear regression model is like this. But this linear regression model won't fit on the logistic regression. That's why here we are using sigmoid function. This is the sigmoid function. So sigmoid function looks like this. Whenever new data points goes like this, the sigmoid function also goes like this. So the distance between the data and sigmoid function is very less here also. So we won't get any miscalculations as mean squared error. Okay. Here we'll get the lot of distance between the data point and linear regression. So we'll mislead with the mean square error. That's why we modified it as the sigmoid function. Sigmoid function means here the probability. Probability is lies between the 0 to 1 always. So regression uses a more complex cost function. This cost function can be defined as the sigmoid function, or this is the logistic function also. So always logistic regression limits between the 0 to 1. Probability always limits between the 0 to 1. Please mind it this. Let's see. What is sigmoid function? The sigmoid function maps any real value into another value between 0 to 1. In machine learning, we'll use sigmoid to map predictions in probability. For example, sigmoid function f of x equal to 1 by 1 plus e power minus x. Previously, f of x, that means y, is equal to beta naught plus beta 1 x1 plus error. That is the equation for the linear regression. But coming to this logistic regression, here sigmoid function f of x is equal to 1 by 1 plus e power x. So we'll get one value if independent variable value substitutes here. We'll calculate a probability for that value. For this f of x, after substituting independent variable, we'll get one value. We'll calculate probability for that value. We'll explain everything clearly. Let's take logistic regression. For example, is the statistical model technique used to predict the probability of a binary and categorical outcome. Here we won't calculate any quotient, that means any relationship between the independent variable to dependent variable. Relationship won't work on this scenario. Here we are calculate the probability only. Probability. It is widely used in various fields, including medicine, some domains which are using logistic regression. Those are the medicine, social science, marketing, some financial, e-commerce, so many domains. Unlike linear regression, which models continuous outcomes, logistic regression with the discrete outcomes. Discrete outcomes means whether it is the categorical data or whether it is the ordinal categorical data. You all know about the ordinal categorical data. That means first rank, second rank, third rank. So these are the ordinal categorical data. There is some measurable difference between the first rank or second rank. There is some measurable distance between the first rank to third rank. These are also categorical data. But coming to the math science, there is no measurable distance. Both are same. But coming to the first rank and third rank, there is a measurable distance between the first rank and third rank. So we'll use logistic regression for the complete categorical data and ordinal categorical data. So how do we calculate probability? For example, it calculates the probability for example, let's take given inputs are these 1 by 1 plus e power beta naught plus beta 1 x1, beta 2 x2, till if we have the n independent variable, so beta 1 x1. After calculating this one, it calculates the, for example, let's assume 1 is the spam mail, 0 is the non-spam mail. Okay. First, it calculates the what is the probability to be the given input as a spam mail. Then after, it calculates the what is the probability whether the given input is a non-spam mail. So it will calculate in two scenarios. Which one get high probability? It says if, for example, whenever we calculate probability whether the given input as the spam mail, if it gets high probability, it says this is the spam mail. If the whenever while calculating whether the given mail input mail is the non-spam, if it comes a high probability for the non-spam mail compared to spam mail, it says the given new input is the non-spam mail. Okay.
Yes, ma'am.
So it calculate, for example, let's say example, you will get one doubt. Madam is always saying 0 to 1 is the probability limits between 0 to 1. Sir, okay, if we have the spam and non-spam, we have the probability near to 0, it is the non-spam. If we have the probability 1, it is the spam mail. Let's consider the multiple categorical data. That means we have the English, science, social, Telugu, maths, some other 10 different languages. We need to classify those one. If we have the 0 to 1 is the probability, how to decide based, how to give threshold for the, for example, let's say we have the, previously I said if the probability is 0 point more than 0.5, it is the spam, less than 0 point, it is the non-spam. How do we put threshold for these to differentiate these 10 languages? People, how do you put threshold for to differentiate these 10 languages? How do logistic regression put threshold to difference these 10 languages? Can I say how it will differentiate? It won't take any threshold value, just it calculates the probability for the each and every language. It calculates the probability of the whether it is the maths or not. It calculates the probability for whether it is science or not. It calculates the probability whether it is social or not. It calculates the probability whether it is English or not. Like this, it calculates the probability for the each and every language or not. Or not means maybe other language. If is this language. For example, let's say maths is 0.3. Probability for this science is 0.2. Probability for the social is 0.1. Probability for the Hindi is 0.25. Probability for the English is 0.8. Okay. So here the maths, science, social, these are getting probability very less. Which subject get a high probability? English. English get the high probability 0.8. So the logistic regression model predicts it is the English language. It classifies the given input is related to the English. Now, are you able to understand how this probability works in logistic regression?
Yes, ma'am.
Yeah. So actually, you people need to ask this doubt. Ma'am, you said 0.5, 0.1, 0 to 1. How do we classify models by putting threshold if we have the 10 classes or 20 classes like that? So it will calculate for the each, whenever new point comes, it calculates for the each and every class separately. Which class gets a high probability? It classifies that is related to the particular class which is having high probability. Okay, this is the concept behind the logistic regression. Here probability of y equal 1x represents the probability of the dependent variable y being 1. 1 means whether it is spam or maths or science or social, anything. What is the probability the given independent variable is related to the particular class, whether it is anything? It calculates the probability for the all classes, which class by using all independent variables. Okay, x1, x2, xn are the independent variable. Beta naught, beta 1, beta 2, beta n is the coefficients. So linear regression directly not fit to the logistic regression. So by using this equation, we convert it as the sigmoid function to classify the logistic regression dependent variable. Okay. Overall explanation. Logistic regression can also handle multiple independent variables. I already explained this one. If we have the n independent variables, it calculates the linear regression equation. After calculating linear regression equation, it substitutes in the sigmoid function. By substituting the given value in sigmoid function, it will get the probability. Based on that probability, it will classify y value. It will classify the independent variable which is related to the which class. For example, additionally, logistic regression can extend to handle multinomial outcomes with more than two categories through techniques like multinomial logistic regression or ordinal logistic regression. Multinomial means if we have the only binary classification, whether a spam or not, that means two categorical data in dependent variable, we called it as the binary logistic regression. If we have the more than two classes, whether 3 or 4, we called it is the multinomial logistic regression. See, in linear regression, there are the two types. One is the simple linear regression, another one is the multiple linear regression. But it depends on the input. So if it is the one independent variable, it is the simple linear regression. If we have the more than one independent variable, it is the multiple linear regression. Here, two types of logistic regression. One is the binary logistic regression. Another one is the multinomial logistic regression. But it depends on the dependent variable. If the dependent variable have two classes, it is the binary logistic regression. If the dependent variable have more than two classes, it is the multinomial logistic regression. Okay. So logistic regression is depends on the relationship between the independent variable and the probability of the event occurring. Event occurring means the probability whether to be a spam to be a spam. Okay. What is the probability to be the independent variable is independent variable means new mail is to be a spam. What is the probability? There is a chance to be independent variable as the spam. What is the probability whether the given input or input mail as a non-spam mail event occurring? It provides insights into the factors influence outcome. Widely used classification is the risk prediction task. Risk prediction task means classification under risk prediction means, for example, let's see, whenever we have the previously I explained fraud, bank fraud or not. Here, for example, let's see the people when customer came to the bank to apply the loan. For example, whether he is fraud, we predicted he is the normal customer. What will happen? Bank will lose their money. Why? Because actually he is a fraud. But the model predicts he is a normal person. So bank will provide loan to him. But he won't return the money. That means bank loss his money. Let's take the new customer is normal customer. But our model predicts he is a fraud. What bank will do? He won't provide loan to that customer. What will happen? The bank reputation will become damaged. If our model predicts two or three normal people as a fraud, so bank won't provide loan for them. What will happen? They go outside. I am the pure one. I have all sufficient income and everything, but bank won't give loan to me. So don't go to that bank. They won't provide loan for the people who are able to repay EMI correctly. What will happen? Bank will get lost their image. So both are risky situations. To predicting fraud as a normal, this is also risk. To predicting normal as a fraud, that will also risk. So this will useful this logistic regression to avoid these type of risk predictions. Okay, not only to classifying the spam non-spam maths class, it will we are able to predict these type of risk prediction tasks. Cost function. Previously, to measure the accuracy of the linear regression model, we used mean squared error or root mean squared error as the metric. Here in logistic regression, this is the cost function. Cost function means the cost function in logistic regression is typically defined as the negative log likelihood function. Negative log likelihood function, also known as the cross entropy loss. For binary classification problem where the dependent variable is either 0 1, the cost function can be expressed as, let's see, 1 by m. Here m is the total number of independent variables. Here m is the total number of independent variables, sigma of, here we actually previously we are calculating directly y by using the independent variables. But here in logistic regression, we are calculating the probability. So here we are calculating probability. So we won't say 0.5. That means for example, let's take if the probability is greater than 0.5, that means 0.6, we call it as the related to the class 1. If the probability is less than 0.5, that means 0.45, we'll predict it as the probability. This probability is related to the class 0. Okay. How do we measure error? So we won't take this 0 to 0.45 to 0. Actually, probability is 0.45. We predicted it as the related to the class 0. If we have taken the 0.45, that is the distance between the 0 to 0.45 is the 0.45. We won't take it as the error. Why? Because it's exactly correctly predicted. If we consider these 0.45 as the error, it become very misleading metric. That's why we'll use y log hx. Hx means probability, predicted probability value. And 1 minus y of log 1 minus hx. Here actually 0. 0 minus y of 0 minus log hx. 0 doesn't have any value. Here what he said, either 0 or 1. Class 0 or 1. 0 minus y log 0 1 0 log 0 minus hx. 0 minus means it doesn't have any value. That's why here y star log hx plus 1 minus y star means multiplication log of 1 minus hx. This is the cost function to measure the error on logistic regression. Okay, by using this formula, we'll measure logistic regression error metric. Here j theta is the cost function. Theta represents the coefficients. Whenever if we want to predict y, we need to know between the here also we are using linear regression equation before calculating the probabilities. See, here also we'll use linear regression equation before converting this linear regression into the sigmoid function. So we need to calculate the coefficients. Those coefficients are the here theta is the coefficient. M is the total number of training examples. That means the total number of independent variable what we used for the to train the model. Y you already know. This is the what we are expecting output. That is the dependent variable. Hx is the predicted probability. Predicted probability means whenever new input comes, we'll predict the probability for whether it is related to the particular class 1 or 0. That probability is nothing but Hx. By using these values, we'll calculate the error. The cost function penalizes the model for large errors in the predicting the probabilities. It approaches infinity as the predicted probability diverges for the actual outcome. So, it penalizes the model for large errors in predicting the probabilities. For example, we have the highest error value. We need to penalize the which independent variable misleads while classifying the model. We need to penalize those coefficients to minimize the cost function. How do we'll say? Here gradient descent. This is what we use to minimize the cost function. Okay, cost function means error. Cost function is nothing but error. If we get the higher error, how do we reduce that error? Gradient descent is an interactive optimization algorithm used to minimize the cost function in logistic regression. In logistic regression, we'll use gradient descent to minimize the cost function. How it minimizes cost function? It adjusts in linear regression also. By adjusting coefficients only, will minimize the mean square error. Same thing applicable here also. It adjusts the coefficients of the theta. Why? Because let's see here. The sigmoid function 1 by 1 plus e power x is the same. So if we want to change probability, we need to change this equation. This is the just equation. Here we are not substituting anything. If we are by changing coefficients, we are able to change predict probability. Okay. So that's what here saying. By changing coefficients, the logistic regression model in opposite direction of the gradient descent of the cost function. For example, if coefficients is in this way, the cost function will goes increase. What we do? We'll do coefficient. We'll try to modify coefficients in the opposite direction. Then only cost function will become decrease. For example, if coefficient values increases, cost function also increases. What we'll do? We'll try to decrease coefficient value to decrease the cost function. Or whether while increasing coefficients, cost function while decreasing coefficients, cost function will increases. What we'll do? We'll increase coefficients to decrease the cost function. Okay, by adjusting coefficient value, we'll try to minimize cost function. How do we do that one? There are some steps. Initial the coefficient theta with random values. Let's take randomly some coefficient value for the each and every independent variable, and then calculate the cost function. Calculate the predicted probability Hx using the current coefficient values. Theta means coefficient values. Calculate the gradient of the cost function. After predicting output value, you can calculate the cost function, whether for each coefficient. For example, let's assume we get the accuracy very low, 0.4%. That means 40%. That means cost function is very high. Cost function is nothing but error. So if the accuracy is 40, that means error is very high. What we do? Update each coefficient by subtracting the small fraction. That means that is the learning rate of the gradient. So while building model, it will automatically learn something. These input values, these particular input value gives a good predictions on the output value. So based on that minimum sense, it will update the coefficient value. For example, if the coefficient increases, cost function will also increases. What it do? It decrease the coefficient value to decrease the cost function. If the decreasing very less coefficient value, due to very less coefficient value, cost function is very high. What it do? Based on that sense, it automatically increases the coefficient value. So automatically cost function will become less. Did you understand?
Yes, ma'am.
Yeah. First, gradient descent. First, it takes randomly some coefficient values. It calculates the cost function. Okay. Let's take. It takes the high coefficients for the at randomly. Due to this high coefficient, cost function is very high. What it does second time, it takes it will subtract some value from those coefficient value. It will recheck what is the cost function. If the cost function increases, what it do? Instead of subtracting, it will add third time to reduce the cost function. Okay. By changing coefficients like this, it will calculate the cost function. For the which values it gives the low cost function, it will finalize those are the coefficient for the given independent variables. Okay. For simply, we'll say, let's take here. I already told you f of x is the function. F of x is called 1 by 1 plus e power x. Let's take one function, that is the x cube plus 5x plus minus 3. Here x2 is the x1 minus f of x1 by f dash of x1. This is the equation. That means what they did, they derivative means I hope all people you have the some knowledge on the derivations. What will become by
Yes, ma'am.
derivating x cube? 3d of x cube. That means this
3x square.
exponent becomes as a multiplier. That means 3x power 3 minus 1. That means 3x square.
Yes.
Here it have the 1. So 5 into 1 x power 1 minus 1. That means x power 0. X power 0 means 1. So 5 into 1 is 5. Coming to the 3. Whenever we derivative constant value, it becomes 0.
Yes.
Okay. So let's come. We need to take coefficients randomly. So let us start with x is equal to 1. Okay. What will it comes? X2 equal to x1 minus f of x1 by x means. That means 1 minus 3 by 8. 8 means f of x means here 1. F of x means this one. 1 plus 1 cube means 1. 5x means 5 into 1 minus 3. 1 plus 5, 6. 6 minus 3, 3. So here it is 3. F dash of x means here 1. 3 into 1 square means 3 1 ja 1 plus 5, 8. What x2 is 0.625. Next time, while adjusting coefficient value, it uses this x2 value is the input. That means x1 minus f of x1 means x in x1 place it substitutes the 0.625. What it comes x3? 0.565. Again, to reducing the cost function, again it takes this is the input. Okay. Again, it takes this output value as the input. What will we get? 0.564. Previously, the cost function is 0.565. Now it is the 0.564. Means slightly cost function reduced. It repeats this step until there is no reduction on the cost function. But that means we can't reduce the error more than that. Till that time, it will repeat this step. Again, it uses this is the input and it calculates the cost function. Again, it uses same output as the input. It calculates the cost function. Let's see. Compare these two cost functions. There is any reduction? Are you able to reduce this one? Reduce or decrease? No. Cost function did not decreases from this to here to here. So, like this, it adjusts the quotient values like this for the each and every independent variable till the minimum cost function. Did you understand how we to adjust coefficients? Here, let's say gradient descent. There are the 4 steps to reduce the cost function. First, it automatically select the random variable as the coefficient. It predicts the probability value. Then after it calculate the error. If the error is very high, but we don't know whether the error is we are able to minimize that error or not. What it does, it will adjust by the given output. It will adjust the quotient value to reduce the cost function. If the cost function reduces, again it try to reduce the cost function. How many times it will repeat this reduction process? Till a cost function reached the minimum value. That means, for example, error rate is the 0.2. We tried in different ways, but we can't reduce that error rate 0.2. Till that time, it will adjust the quotient values. This is the example problem. Let's take. We have the independent variable. Let's take this function. This is the x2. This is the function for the gradient descent function x1 minus f of x1 by f dash of x1. That means derivation. This is the function. This is the derivation of this function. Let's start. It takes randomly x as the 1. That means this is the coefficient. Coefficient value is the 1. Randomly it takes. By substituting this 1 in this function, this gradient descent function, it gets the 0.625. This is the cost function. Okay. But we need to minimize this cost function till the minimum. Till the minimum means from that value we can't reduce. We need to decrease cost function till that value. From that value, no one can't reduce that cost function. That is the minimum, global minima value. What we'll do, we'll adjust quotient each and every time to decrease the cost function. Let's see. Here 0.625. It reduces to the 0.625 to 0.565. 0.565 to it reduces to the 0.564. 0.564100072. It reduces to the 0.56009973. From this, it won't able to reduce the cost function in the next step. Okay. Previous cost function repeated in this step also. That means we can't reduce our cost function more than this. So it will reduce the cost function till the minima. Okay, guys, are you able to understand?
Yes, ma'am.
Yes, ma'am.
Yeah. This is the gradient descent, how cost function will reduce by using the gradient descent function. This x cube 5x means this is the beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. That function is this f of x
This is
function.
a recursive function, right?
Yeah.
This is a recursive function, right?
Yes. So that is the function. By changing coefficients like this, it will reduce the cost function. Here, the learning rate determines the step size taken in each iteration. If the learning rate is too small, the convergence may be slow. On the other hand, if the learning rate is too large, the algorithm may fail to converge. For example, let's see. Learning rate is nothing but this one, these output values. If the learning rate is very small, that means we are able to do something. If the learning rate is very big, that means we iterated 10 times, 100 times, but the learning rate it reduces very, very less. That means what it is called algorithm may be failed to converge. What we assumed first, let's see, the first assumed value is correct. That means we are able to minimize first function. If the random what we selected random variables are not correct, the cost function won't be reduced. What we'll do? We'll again randomly assumes other coefficients. Okay. The gradient descent algorithm iteratively adjusts the coefficients, gradually reducing the cost function. It iteratively adjusts the coefficient repeatedly. Iteratively means repeatedly it adjusts the coefficient to reduce the cost function until it reaches a minimum or an acceptable level. Minimum means we can't reduce cost function more than that. Or, for example, let's see, cost function is if client are able to bear cost function till 0.3 or 0.36. Once we reach that cost function, we leave. Okay. If client won't say any threshold, we'll try to reduce cost function as minimum as. If he give any acceptable threshold, we'll try to minimize our cost function to that acceptable threshold value. Okay. The final set of coefficient represents the values that minimizes the cost function. Which coefficient set, for example, which value here, this value, which value, not this one, this value gives the minimum. So this is the final coefficient value to minimize the cost function. Okay. The final set of coefficient represents the values that minimize the cost function and provide the best fit for the logistic regression model. So logistic regression model takes these coefficients which are gives the very minimum cost function. It finalizes that these are the coefficients for to predict the whenever new input comes. Okay.
Ma'am,
Okay. Let me.
automatically there is no on any other software like or any detection technique to automatically reduce the cost function.
We have the
Ma'am,
so many parameters.
yeah, there are many parameters, but like when we are getting the independent variables, obviously the cost function will be depending on the independent variables, right?
Yes, definitely.
Yeah. Then is there any technique that it will automatically reduce the cost function without by coding it?
Without by coding. Coding means
Directly by coding it. So why is there any chance to directly reduce the cost function?
coding means you are talking about the Python or C language code.
Yeah, by using any other technique like by coding technique.
Yeah.
Yeah, is there any chance of reducing it directly?
Coding technique we can't use, but we need to give parameters. For example,
Parameters. Initially we'll be giving some parameters, right? After that
okay.
we'll not be giving. As it is a recursive function, it will be going on doing that until the lowest value, whatever comes.
No, through code, for example, let's see, we have this code for the to reducing the cost function for the logistic regression. Why do client will recruit data scientist? They will take one code, they will give input to that code. It will automatically reduces the cost function. It will gives the good predicted value. So they will use that code for the each and every scenario. Why do they need data scientists? No, there is no code or there is no package, there is no model which is gives the good results. The data scientist who working on that, they need to understand data, they need to change parameter based on the output value, they need to pre-process the data. Everything first we need to prepare code based on the our input data. So one skeleton or one script one way, not set for the all different types of domains, different types of models. See, based on the bank data, we need to use some parameters. We need to follow some data pre-processing steps. Coming to the some pharmaceutical, some other data, we need to follow some data for example, let's take we have the numerical data, categorical data. String data means the text. For example, uh, you can take gender. They will write male, female, transgender, like that. Some data will comes like that. Some data they will give 0, 1, 2. 0 is male, 1 is female, 2 is transgender. We don't know how data will come. But whenever we'll try to do something by using laptop or computer, we need to convert each and every string as a numerical. Why? Because computer knows only 0 ones. Computer don't know any T, A, B, C, D. So based on the data, we need to pre-process data, we need to build model, we need to based on the results, we need to find what is the reason behind we are getting high cost function, what is the error. Based on that reason, we need to change our data or our parameters to build a good model. Okay.
Yes, ma'am.
So out of the all methods, gradient descent is the mostly popular method for the logistic regression. So to enabling the model to learn from the training data, make accurate predictions. We'll use different functions for the different models. For the linear regression model, we'll use mean square error or root mean square error as the parameter to find the error. Here we use the cost function is the parameter to find the error in logistic regression. Here gradient descent is the another technology to reduce the cost function. Okay. Anybody have in logistic regression we won't fit this linear regression value. That's why we'll use sigmoid function. Sigmoid function is nothing but
Ma'am,
after
logistic regression will be used for the only continuous data, right?
discrete data, that means categorical data. Linear regression will
Linear
useful
is
for
for
the
continuous
continuous.
data.
Yes, continuous.
This is for the only discrete data,
Yes.
so
The
that it will be
sigmoid
plotting easily.
yes. So this logistic regression uses sigmoid function to classify the classes. Sigmoid function is nothing but the probability. Probability is always lies between the 0 and 1. For this one, the equation is f of x. That this is the function of the sigmoid function. 1 by 1 plus e power minus x. X is the linear regression model. After so directly linear regression model won't useful to classify the method. We need to change this linear regression to the sigmoid function. That's why we'll use this function. In logistic regression, we'll calculate the probability for the given class. If we want to check if there is that three variable, we'll check for the probability for each class. Which class I have get high probability, we predict this input variable is related to this particular class. So this is the function. One here, 1 by 1 plus e power x, that means 1 by 1 plus e power this linear regression equation, beta naught plus b1 x1. So by using this function, it will calculate the probability. Here, this is the probability of the outcome. X1, x2 are the independent variables. Beta 1, beta naught, beta 2. These are the coefficients. That's one. And logistic regression, there are two types. One is the binary logistic regression. Another one is the multinomial logistic regression. If we have the two classes in dependent variable, we call it as the binary logistic regression. If we have the more than two classes in dependent variable, we call it as the multinomial logistic regression. So here we'll calculate the probability of an event occurring. For example, probability of whether this mail to be a spam or probability of whether this mail to be a non-spam. Which probability is high, it will predict it as the related
Ma'am,
to that
temperature
particular class.
it will be coming
Temperature.
under discrete data, right? Like every day's temperature we can measure in the discrete thing, so that we can use logistic regression.
Temperature, let's see. Today maybe temperature 40, tomorrow maybe 41. There is a chance to 20 to 41. There
Yeah.
is there is measurable. There is a chance to continuous one. It won't become a discrete.
But
Discrete means categorical data. There is no difference. For example, let's see if the temperature is 20, temperature is 40. There is lot of difference. Temperature is 20 means there is a chance whether it is a winter season or rainy season. If the temperature is 40, that means very high temperature. It is maybe a chance to the summer. There is the measurable distance. Coming to the categorical, for example, whether it is a spam, non-spam, there is no distance, though there is no measurable distance between the spam and non-spam mail. So that type of data is the categorical data. But if we want, we can use logistic regression for the temperature prediction also. Let's see. I said logistic regression is a classification model. We'll use to predict the whether the data point is classified to the particular class or not class. We'll use same logistic regression for the um, continuous variable also. How do we use? You will get that type of idea whenever you try to build model. How do you use logistic regression with continuous variable? If you need to get that idea, you need to build model. But in this situation, you won't get that type of knowledge. So for now, you can use logistic regression for the classification. We'll say in future how to use linear regression for the logistic classification, how to use logistic regression for the continuous variable. Okay.
Okay, ma'am. Yes,
Yeah.
ma'am.
This is the cost function. We'll use log likelihood. Negative likelihood is the cost function for the logistic regression. This is also lies between the 0 to 1. Here, this is the function only. These are some parameters. J theta is the cost function. M is the total number of independent variables. Y is the predicted value. H of x is the probability. By substituting these predicted value, probability, and number of dependent variables in this equation, we'll get the cost function. After getting cost function, we need to reduce that cost function. To reducing that cost function, gradient descent will be useful. What it do? It will take randomly some coefficient and it will calculate the cost function. By using the cost function, it will adjust the coefficients. By adjusting this coefficient value, it will try to reduce some cost function. It will adjust these coefficient value repeatedly until the cost function goes to the minima or the cost function goes to the acceptable value. Minima means we can't reduce cost function more than that. We need to reduce cost function till that. If client says we are able to accept this much cost function, that means this much error 0.4, 0.6, like 3, like that, we'll try to minimize that cost function to that acceptable value. Then after we'll leave that. So this gradient descent reduces the cost function till the minima or till the acceptable value. This is how we do. Let's assume this is the one function. This is the gradient descent function. We have the three functions. One is the sigma function, 1 by 1 plus e power x. That is just by to converting linear regression to the logistic regression. To finding the cost function, there is one function, that is the j theta. To reducing this cost function, we have the gradient descent technology. That gradient descent function is x2 is equal to x1 minus f of x by f dash of x. Means derivation of the f of x. So by take randomly one value, it calculates the sum cost function. It uses same output repeatedly till the cost function goes slow. After reaching some cost function minima value, it won't reduce more than that. Like this. See, by using this value, it gives us this cost function. By using this value, it gives the same cost function. So we can't reduce cost function more than this. Okay. Anybody have any doubts?
No, ma'am.
Okay.
No, ma'am, no.
Yeah.